All right, today's lesson 5.3 in your algebra book. We're going to continue kind of working with the fractions that we've been working on simplifying. We've been looking at multiplying and dividing algebraic fractions. So today we're going to look at rates, which is kind of going to be working with the same concepts, but maybe putting some context to it, so some real-life application. So today's big idea is that the quotient of two measures with different units is a rate, and that's our first definition as well. Okay, so when we have different units, it's like talking about miles and hours and comparing the two together. That becomes a rate. So if you divide miles by hours, then you have your rate. So miles per hour is what you get. Now the reciprocal rate is the inverse of a given rate. So if we have miles compared to hours, the reciprocal rate would be hours compared to miles. So how many miles per hour? So how many miles do you go in 1 hour? Or how many hours per mile? How many hours does it take to go 1 mile? So whatever's on the bottom is for 1. So this is miles per hour. And this one is hours per mile, and they're different. All right, so let's jump in. We're going to calculate example number 1. So Tanya and Gary drove 400 miles in 8 hours during a trip. So we're going to calculate the rate that is suggested. So we're going to compare miles to hours. A unit rate is always for 1. And that's basically what we're going to be working with today. So if you took your 400 miles and you divided it by 8 hours, we are going to get miles per hour. So you can read it from top to bottom. If you're confused about which way to divide it, do I do miles per hours or hours per mile? All right, it's going to depend on what unit is more appropriate at the time, but we read it from top to bottom, miles per hour. Okay, and if we do 400 divided by 8, we get 50. So if you went on a steady trip, 400 miles in 8 hours, you were driving 50 miles per hour. 1 hour. 50 miles for 1 hour. Okay, so during a storm, 4 inches of rain fell in 2.5 hours. So do we want to know how many hours it took for 1 inch, or how many inches fell per hour? So normally we're going to go inches per hour. So if it helps you to set it up, forget the numbers for a second and just think about what makes more sense. What do I need? Inches per hour or hours per inch? Set those up, inches per hour, and then throw the numbers in. And I think it'll help you set those up. So this is going to produce inches per hour. So how many inches fell in 1 hour on average? So 4 divided by 2.5, and you're going to get 1.6 inches per hour. So last one, Danielle walked her dog 6 blocks in T minutes. So do we want to know how many blocks per minute or how many minutes per block? Depending on the situation, you may need one or the other. So let's just go with the order that was given. How many blocks per minute? Blocks per minute. And so the blocks were 6 and the minutes were, we don't know, T. So we're going to express this as 6 over T blocks per minute. And as soon as you knew the minutes, you can go ahead and plug it in and do 6 divided by that to find out how many blocks per minute. All right, now we're going to use these rates to express the rate of change over time. So if the temperature rises from 75 to 85 degrees in 2 hours, what is the rate of change? And now this is going to produce an average because clearly it could have gone from 75 to 85 in 30 minutes and then stayed steady for the rest of the 2 hours. So this is just on average throughout the 2 hours. So first of all, we need to figure out how much it changed. So obviously we could do this in our head, but it's a 10-degree change. You subtract the 2 to figure out how much the change was. And now you need to think about, did it change for the positive or did it change for the negative? So the temperature rose, so that's a positive change. So when we express our answer, we want to express it as a positive number. So it was a 10-degree change. So 10 degrees in 2 hours. And so when I get my number, it's 5. And it's read from the top to the bottom. Degrees per hour. So on average, if it took 2 hours to rise 10 degrees, it was changing 5 degrees per hour. Again, we don't know if it was steady change or if it was quick and then it was held steady, or it didn't change at all for a little bit and then it went up really quick. Okay, but on average, 5 degrees per hour. 5 degrees the first hour, 5 degrees the second hour, and we've got 10 over 2 hours. So what about if the temperature drops from 44 to 32? So first of all, how much did it change? So from 44 to 32, that's a 12-degree change. And it dropped. So we want to express this as a negative number because it dropped. So what was the change? So we're going to say it changed negative 12 degrees in 5 hours. Now if we divide that, you're going to get negative 2.4, and this is degrees per hour. So we're going to use positives and negatives to express the rise or the fall. So if you see a negative in terms of change, you know it was going down, obviously, and if you see a positive, then it was going up. All right, so let's flip it over. So we've talked about positives and negatives. What about 0? How does 0 play into this? So a fraction is equal to 0 when the numerator equals 0. So if you had a 0 on top, you can divide 0 by something, and the answer is just 0. In terms of a rate, 0 meters in 10 seconds. So how far are you going? You're going 0 meters per second. You're not moving. 0 meters per second. But you can't divide by 0. We've talked about that before. So a fraction is undefined when the denominator equals 0. So you can't divide by 0. So 10 meters in 0 seconds, that's just undefined, because how could you travel a certain distance without any time passing? Okay, it doesn't even make sense in the real life situation. All right, so let's look at some specific algebraic fractions here. When should they equal 0? For what values? And then when would they be undefined? So for the first one, for what values of x is x over x plus 4 equal to 0? So if this fraction was going to be equal to 0, that means the numerator, because when it's equal to 0, it's the numerator, has to equal 0, not the bottom. So numerator must equal 0. So for this case, when is this fraction equal to 0? When x equals 0. So same fraction, for what values of x is this undefined? So if it's undefined, the denominator must equal 0. So not x, the denominator. So something has to get plugged in for x to create a 0 down here after we've added 4. So if we take x and we add 4 to it, we need to get 0. This bottom needs to be 0. So again, not x, the entire value of the bottom. So if I minus 4 here, x is going to equal negative 4. So if I plug that in, negative 4 plus 4 is 0, and that makes this fraction undefined. So when x equals negative 4. So last two. For what values of x is this equal to 0? So again, that would be the numerator. So x plus 2 must equal 0. So what's the value of x? Negative 2. X equals negative 2 for this to equal 0. And for what values make this undefined? So that's going to be the denominator. When does the denominator produce a 0? That's when x equals positive 3. If I plug in a positive 3 and I minus 3, that becomes a 0, and that's undefined.